Tonight's video looks at cloud formation and the types of clouds. It's going to build on what we talked about today with relative humidity, and we'll see that when relative humidity reaches a certain point, we get cloud formation. So, cloud formation happens when warm air rises through the troposphere and cools. So we have warm air rising in the troposphere and cools. Right? We can see that in the picture here. The sun's heat comes down, heats the air up. As it rises through the troposphere, it starts to cool off, and that becomes important. As it cools, water vapor condenses into liquid droplets or ice crystals. So since the air is now so cool, the water vapor can't stay as a gas, it becomes a liquid, but it can't just float in space. You can't just have floating water. It has to condense on small solid particles, such as smoke, dust, or pollen. So let's see what happens then to the air as it's rising. As the air rises, we're going to reach this point that we call a dew point. So the dew point is the temperature where relative humidity reaches 100%. So that's a little confusing. Let's come back to our diagram that we looked at in class today. Right, here's my air. Right now it's got a relative humidity of maybe 45%. As the air cools, right, as we're rising into the atmosphere, the air is cooling, that maximum amount of water that the air can hold shrinks. Right? And at some point, at some temperature, the relative humidity is at 100%. And so right here, this would be the dew point for this air. All right? And so if the air keeps cooling, if the air cools past the dew point, we have too much water vapor. Right? If we keep cooling off, we now have passed the dew point. There's too much water vapor for the air to hold. Right? So with this diagram, these three rows all fit, but this row is extra. It doesn't fit anymore. And so this extra water, when we've cooled too much, condenses into a liquid and forms a cloud. All right, I'll slide that over so everybody can see. So the extra water condenses into a liquid and forms a cloud. So as we cool off, we get past the dew point, this extra water has to condense, and we form a cloud. The reason why clouds are usually so high up in the atmosphere is because only that high up do you get cool enough for clouds to form, for this water vapor to condense. If you were down closer to the surface, the temperature would be warmer, and there's enough room in the air to hold all the water vapor. So let's quickly look at types of clouds. We have three main types that you need to know. And this, for most of you, is probably a review. Our first type are cirrus clouds. These are wispy, high altitude. By high altitude, we mean 6 kilometers and up. All right, these are our thin, wispy ones up here. We also have cumulus clouds. All right, these are, they look like cotton. Usually mean good weather, all right, and they are lower. They're maybe 2 to 3 kilometers above the surface. So we've got cumulus over here. And our last main type is stratus, right, which is a covers the sky like a blanket, so it's a low, flat layer, maybe 1 to 2 kilometers up. And then our last one is fog. And fog is just a cloud at ground level. So when you're in fog, you're literally in a cloud. So instead of the cloud being at 3 kilometers, the cloud is down at ground level. Now, some types of clouds bring rain, and the word nimbus is a prefix or suffix that means rain. So a cumulonimbus cloud is this huge cumulus cloud that brings rain. We'll see often brings thunderstorms. A nimbostratus cloud is going to be a stratus cloud that brings rain. And the reason you would rain is you have so much condensation earlier that now you have too much water in the cloud for it to stay in the atmosphere. These droplets link together and fall to Earth. So make sure you do your summary, make sure you fill out the survey on the website, and I will see you guys in class.